If you've been watching my channel for a while, you know I'm a freak over LEDs. So Auxbeam, which I've already done reviews for them before, sent me in another LED product. This time it is a 22-inch light bar for cars, trucks, stuff like that. And it's big enough that I can't even fit it all right in my regular viewing angle. So work with me here. So inside the box, we can see the light bar protected fairly well. We got, let's see here, a little bit of information, how to contact them. Let's get that out of the way. Yes, I've already looked at this once. And if we come on over here some more, we have some other stuff. We got some mounting hardware, and they even give you an Allen wrench, which we'll get to more later on. We also have the really big wiring harness, which of course we will expand on this a little bit further. And there's a positive negative for the light bar itself. Let me get it out of the box so we can actually see it. Okay, time for the big reveal. Okay, here's one side. Come on over. And here's the other side. Yeah, this is a 22-inch light bar, and it has a couple different things going on here. First, it's IP67 sealed, which we're going to check that later on once we open this up and actually take a look inside. But it also has this main section from here to here are basically projection LEDs meant to really shoot the light out forward in front of you. And then on each side, 8 over here and 8 over here, are more of a dispersed floodlight, so this way it fills in the side. So that's pretty freaking cool. Let's run it at 12 volts off my bench power supply and see how much power it actually pulls. And we're just going to skip the wiring harness for the moment. We're going to wire it directly on in and see what it does. Okay, so I have it wired into my bench power supply, and I have it set for 14.1 volts to mimic a car actually currently running. The engine's running, the battery's charged, and I have it up to 10 amps availability, which I'm sure we will not exceed. So let's turn on the power supply and see what happens. Whoa, yeah, holy crap, that's bright. Let's see here, pulling 14.1 volts at 5.4 amps, which is 76 watts. Okay, so it's pulling 76 watts. It is rated for 120 watts on their website, so it's running a little on the low side. But even if it is, it's still really bright. I'm not sure if my camera will compensate for this enough. Okay, it compensated fairly well. But you can see how these over here actually do more diffusion, whereas these are more projecting. Let's slide on over here. So what we're going to do now is take a baseline temperature of this thing running right now and then let it run for 10 minutes. And this would be like a worst case scenario. You got the light on, you're not driving anywhere, you don't have any air coming over it to keep it cool. So let's see what we get here. This has already been running for about 2 or 3 minutes. And looks like the highest I got was 88 degrees. So let's let it run for 10 minutes and see how hot it really gets. If we look on Amazon for this unit, we'll see here, it costs $55 for the unit. Scrolling down here, where's the main information here? Yep, 22-inch with 40 pieces, 3-watt intense Cree LED. And they put it as a rating of 120 watts, even though we're only using 75 watts. 40 pieces, 3 watts. Working voltage 10 to 30 volts, fits 12 to 24 volt vehicle. I'm running it at 14.1 volts to mimic a regular 12 volt car running. Luminous flux around 12,000 lumens. Color white 6500 Kelvin. I can see it projecting on my wall. I would probably say, yeah, probably about 90% of the projection is about 6500 Kelvin. It's really white with a slight blue tinge to it. Beam angle, spot 30 degrees and flood 60 degree combo. Protection rating IP67. Working temperature -40 to 85 degrees Celsius. There's the sizes for you. And about 50,000 hour lifetime. So now we've been sitting running for 10 minutes The power supply is still running 14.1 volts at 75 watts, so that hasn't changed at all in the 10 minutes that it's running. So let's get some temperature. It's definitely warmer. Okay, we're looking at about 111 around here, 113, 115, 116. Still not bad. Not bad at all. This is definitely the cold side over here. We're only at like 108, 107, 108, 105. 105 is about the lowest I've seen, and 116 is about the highest. And this is definitely the cold side, away from the wiring, which is over here. Here's your wire inlet, and this is the cold side. So when we pull it apart, we'll have to see. There must be more electronics running over here. So let's go ahead and let this cool down for a few minutes, and then we'll pop it open and see what actually makes it tick. Okay, so we're going to continue taking out all these screws to get the front off with a 2mm Allen wrench. Okay, so I got the top bar unscrewed so far. These are definitely metal. The glass is actually a plexiglass, I can tell that, and this is being used as a retainer. So let me go ahead and finish unscrewing the rest of it, and we'll keep going. Ooh, come on, almost off. There we go. Okay, so yeah, this is just probably 1/4 inch plexiglass. Not bad. The seal, on the other hand, sits in its own little groove in here. Once I put it back in there. And yeah, I think that will, at least the front of it so far, will qualify for IP67. So let's get that seal up and out of the way so we don't accidentally damage it. On second thought, I think we're going to leave it in here, because it looks like they may have glued it in the corners here. So I don't want to rip it. I'll just be careful. Yeah, it's glued in on the corners. So I'm just going to leave it in here and try not to mess with it too much. And we'll continue onward. Now it looks like each single set of either projectors or the reflectors, they come in pairs of 4 with each screw. So let me take out each screw and we'll see what's underneath there. There we go. Okay, so the reflector housing is plastic. Actually, the whole thing seems to be plastic. Definitely a longer screw for it. So we'll put those to the side up here. And inside, at least what we initially see, these really nice little small 3-watt LEDs on a very big, probably an aluminum-backed circuit board. So let me get the rest of these reflectors all out of the way, and we'll keep on going. So I got all the lenses out now, and here's the side with the wire coming in. You can see your positive and your negative down here, right there. And we have a white aluminum-backed circuit board tied directly into the back of the heatsink spreader, and we can even tell right here, yes, it's actually a liquid thermal compound. So they actually do have thermal compound behind this as well. I really don't feel like pulling this up. I don't see a need for it. But as you can see, here's the other side. It's a very simple circuit board with all the LEDs just strung in here. And let's see if I can get both of them here. Now, there's a little 6-pin IC on both of these little sections. There is no identification marks on these whatsoever. I'm going to assume this is a MOSFET. I tried looking up the part number on this online. Still can't find anything on it either. We also have 2 high power inductors and 2 diodes, a few controlling resistors and smoothing capacitors, and 2 more diodes. You know what this screams to me? It's nothing more than a buck converter. So half the board's being ran by this one, half the board's being ran by this one. Very simple. The only thing I notice is we're missing the C3s, capacitor 3 on each one, and capacitor 4 on each one. So I don't know why they decided not to put them in there. Maybe they didn't need it for stability, but it seems to work perfectly fine without them. So I guess it was just a cost-saving measure at that point. So let's go ahead and put this all back together and let's install it on a car. Okay, so now I have it reassembled. Got all the lenses and the cover, front cover back on. I wanted to point out 2 things before we get outside. One, I did put 2 male connectors on the wires that they have here. And the other thing is the only other opening for water to possibly get into is where this wire goes in and out. And there is a pretty thick grommet sitting right here. So you really have to hit a ton of water before anything gets in there. That should be good enough for IP67. Just wanted to let you know that. Okay, so first figure out where you want to put it on the car itself, and you're going to drill 2 holes with a 5/16" drill bit for your little mounting spots, which is really nice. We already attached them. They also come with these little rubber pieces that the bolt actually holds onto perfectly. So let's go ahead and finish the install of the unit itself, and then we'll get to the wiring. Okay, so now that we have the light mounted to the front bumper, let's move on to the wiring. 4 things you're always going to need when you're doing wiring: cutters, zip ties, heat shrink tubing, and a heat source. Okay, the first thing we're going to do is take the relay and just zip tie that off to the side, since that's basically the central part of the wiring harness. And then we're going to connect the negative. And the positive. Okay, so we'll zip tie the extra positive wire out of the way. And we'll start running the wires that go down to the actual light bar. We'll start fishing it down and around, down to the light bar itself. Get it out of the way. Now let's connect positive and negative. Push your little plastic protectors over it. And bring the heat shrink tubing back. And get yourself a nice little heat source. And this is just to protect the connection. Now, before we actually run the little control button into the dashboard, since we have it easily out here, let's go ahead and test it. It's going to be kind of hard for you to see right now, but there is a red light on since we did connect the battery already, saying the light bar is off. And there we go. It's on, off, on, off. So let's go ahead and install this in the dash and wire tie all the extra wires out of the way. And here we have it mounted right to the left of the steering wheel, right where I have your illumination controls, your traction control, and here's a light bar, and then the crazy little lights that go around the speakers on the 2014 Kia Soul. So now we just gotta wait till nighttime so I can actually show you the final results. Okay, so now we are facing the vehicle at night, and I have the exposure locked on my camera. So let's walk over, because we only have the parking lights on right now, and show a good test. So first, here is the low beams. Now the high beams. And finally, the new light bar. Wow. Okay, and one more time now by the side of the vehicle so you can see how it projects. So right now it's parking lights. Now we're on low beam. Now we're on high beam. And finally, the light bar. It is extremely bright. It definitely does do the floods to the side a little bit, but it's not very bright. But considering how many projection beams there are in the center, it has a really strong hotspot. So if you're, I guess, out in the woods and you're looking straight down a very long lane, oh my god, it would definitely illuminate it. So there's the review, the teardown, and the installation of the Auxbeam 22-inch light bar. It runs about $55, so it runs about the normal price. Granted, there are other bars out there that are 22 inches and cost like $25 on Amazon. Honestly, I wouldn't trust them. That's kind of too cheap. It's probably going to either leak, corrode, not work, or give crappy performance. Now granted, this one has one heck of a hot spot, and this is my first light bar, so I don't even know if that's normal for them, but it works great for what I need to do, so I'm happy with it. I'll leave links for everything down in the description. Thanks for watching, thumbs up, and I'll see you next video.